All right, let's dive right into this explainer and completely shatter, literally tear apart everything you thought you knew about gravity and floating in space. We're going to look really closely at the actual physics of weightlessness and how, from a certain point of view, we can literally eliminate gravity. My goal here is to guide you through this mind-bending material so that by the end of this, you're going to view your own connection to the solid ground beneath your feet in a completely different way.
So, you see astronauts floating around on the International Space Station, right? Having a great time during flips. But here is the crucial question. Are they actually experiencing zero gravity? Well, actually, no way. The Earth's gravitational field at the altitude of the ISS is still practically 90% as strong as it is right here on the surface. So, if all that gravity is still there, tightly holding the station in its orbit, why on earth are the astronauts floating around as if someone just flipped a gravity switch off?
To figure that out, we have to start by destroying a really common misconception. Section 1. The weightless illusion.
Okay, so weightlessness isn't just floating around like a submarine in the ocean. If you stood on a bathroom scale inside a submerged sub, you'd still weigh exactly the same because the floor is still pushing up against your feet. True weightlessness is the exact sensation you get in the literal very first second of a bungee jump. You are in free fall. If you somehow strapped a scale to the soles of your feet during that initial plunge, right before the air resistance really kicks in, it would register absolute zero. So weightlessness is simply the physical state of being an unhindered, total free fall.
And honestly, this brilliantly illustrates that free fall doesn't just mean moving downwards. Think about these kind of surprising examples. A rock thrown straight upward, it is technically in free fall the exact split second it leaves your hand, even while it's still traveling up. A rock drifting all alone out in interstellar space? Yup, free fall. And a satellite, or the ISS for that matter, is continuously in free fall, basically just constantly falling around the Earth. The word free is the absolute key here. It means the motion is completely 100% free from other influences, like air resistance or the ground pushing back up at you.
Let's see how this builds into one of the absolute most important concepts in modern physics. Section 2. Einstein's falling elevator.
Einstein challenged us to do a little thought experiment. Imagine a guy inside a large enclosed box, like a windowless elevator. In the first scenario, this elevator is just drifting out in deep, dark space, millions of miles from any planets. The guy inside just floats weightlessly. Makes sense, right? In the second scenario, imagine some super powerful being hooks a cable to the elevator and pulls it upwards at a constant acceleration of exactly 9.8 meters per second squared. Suddenly, boom, the guy feels weight. He gets planted firmly on the floor. Now for the third scenario, imagine that exact same elevator falling freely toward Earth. Einstein realized something incredibly profound here. Locally, inside that closed box, you absolutely cannot tell the difference between floating in deep space and falling freely in a gravitational field. It's impossible.
So the mind-bending truth here is that a freely falling observer is actually an inertial observer. Think about it. If our falling guy empties his pockets, his pocket watch and his coins aren't going to fall to the floor of the elevator. No, they'll just drift perfectly alongside him in midair. This exact realization led Einstein to his famous equivalence principle. Basically, within a small local frame of reference, the effects of gravity and the effects of being accelerated are physically indistinguishable. For the guy in free fall, the gravitational force has effectively been completely eliminated. He feels absolutely zero physical gravitational force. In this sense, gravity is literally treated as a fictitious force.
But wait, if gravity isn't a true physical pulling force that you can actually feel while you're in free fall, what on earth is it? Let's reshape how we look at the entire universe. Section 3. The geometry of space-time.
For centuries, Isaac Newton saw gravity as this instantaneous pulling force acting across vast distances between masses. The Earth pulls the apple pulls the Earth. But Einstein came along and revealed that gravity isn't some invisible tether pulling things through space. It is actually the geometry of space-time itself. Mass doesn't exert a direct physical pull. Instead, mass actually curves and warps the very fabric of the four-dimensional space-time manifold around it. Sort of like placing a heavy bowling ball on a trampoline.
Now, I absolutely love this next bit because it so elegantly breaks down the relationship. The green metric field you see here, which is just a fancy way of saying the geometry of space-time, dictates how everything else moves. It acts as the influence. But look right over at the return arrow. Everything else, meaning all the matter and energy in the universe, reciprocates by actually modifying and curving that exact same geometry. It's this beautiful cosmic dance. Matter tells space-time how to curve, and curved space-time tells matter how to move.
So how exactly does matter move through this curved geometry? Well, objects don't just magically get yanked off their paths by some mysterious invisible force. They simply follow the straightest possible lines available to them in a curved universe. And these straightest possible paths, they're called geodesics. Imagine two people standing on the equator miles apart, and they both start walking perfectly straight north. They aren't actively steering towards each other, right? But because the Earth is a curved sphere, their straight paths will just naturally converge and cross at the North Pole.
This brings us to a massive, profound realization about how things actually move through the cosmos. Section 4. Geodesics, the straightest path. When you hold an apple and drop it, you obviously see it accelerate toward the ground. But from the perspective of general relativity, that apple actually has zero proper acceleration. Seriously, if you somehow attached a microscopic accelerometer to the apple, the reading would be exactly zero during the entire fall. The apple is simply coasting. It's just following its natural, unforced geodesic path through a curved slice of space-time. It literally requires zero force to free fall.
But wait a second. We have a little puzzle to solve here. Is there any way for our guy in the falling elevator to actually detect the giant planet beneath him without looking outside? Let's uncover this in Section 5, the tidal force truth.
The answer is found in what physicists call tidal forces. If our falling elevator was gigantic, like ridiculously huge, and we placed two floating spheres really far apart inside of it, something super fascinating would happen. Because both of these objects are naturally following their own geodesics that point toward the exact center of the Earth, their paths aren't actually perfectly parallel. They converge. So as the giant elevator falls, the observer inside would slowly, almost imperceptibly, see the two spheres drift slightly closer together.
This convergence, these tidal forces, are the ultimate, undeniable proof of space-time curvature. And if we look at the energy-momentum tensor here, wow, we see that it's not just the sheer mass of the planet causing this geometry to warp. It's actually the total continuous distribution of matter, energy, momentum, and pressure that curves the manifold. That is the true underlying signature of gravity, and it's something you cannot simply transform away or ignore just by falling.
Okay, so let's tie this whole shebang together, because this is the part that completely changes how you experience the physical world right now. If free fall is your actual natural unaccelerated state, your true geodesic, where an accelerometer reads a perfect zero, then standing perfectly still on Earth means you are actively deviating from that natural path. By just standing on the ground, you are the one experiencing absolute acceleration. Your personal accelerometer, right in your pocket, is reading 9.8 meters per second squared right at this very moment.
I really want to leave you with this totally mind-bending thought to chew on today. Gravity is not some invisible rope pulling you down. Instead, the incredible mass of the Earth has physically warped the space-time around it. And your natural, inertial state in that warped space-time, it's to be in free fall, to be completely weightless. The absolute only reason you feel weight right now is because the Earth's surface is physically getting in the way, violently and continuously accelerating you upwards against your natural path. So, if weightlessness is your true natural state, what is the ground doing to you right now?
I'm chasing the stars, but they all fade away.